So yesterday we introduced this concept of diffraction. And as you remember, diffraction is the spreading out of a wave. It can be through an opening or it can be around a barrier. Okay, we have, let's say, an opening right here with water waves coming towards that opening. Okay, water waves coming this way towards that opening. Most of those waves are going to reflect off of the barrier, the concrete barrier, the rock barrier, whatever it is. But there's going to be a few of those waves, a little bit of those waves that goes through the opening. But it doesn't just go straight through the opening. When it goes through the opening, it spreads out around the opening like this. That's called diffraction. Now, what we can also see is maybe you've got some kind of wall or something like this, maybe some kind of concrete barrier like this, with the wave going like this. Well, that's not going to go through any kind of opening, but as it goes around the corner, it spreads out like this. Okay, it spreads out like this. That's why when I open the door, somebody can hear me down the hallway because the sound waves spread out as they go through the opening. Does that make sense? Okay, that's diffraction. Now, sometimes diffraction happens a lot. Sometimes diffraction happens a little bit. And there's three things that affect the amount of diffraction that we get. Thank you. The size of the opening. We talked yesterday about the size of the opening, how the smaller the opening, the more diffraction we get. So let's say that you had this door and you were trying to actually get more diffraction. Okay? In other words, stand right behind the corner of the door, you would actually hear me better if the door was a narrow opening. You get more diffraction, more spreading out when it's a narrow door or when it's a narrow opening than a wide opening. Okay, so you want a narrow opening. That gives you more diffraction, more spreading out. What about the frequency of the wave? Well, if you remember my story yesterday, we said that when I listened to AM radio, I couldn't hear the radio station at the bottom of the hill. Sorry, I could hear it at the bottom of the hill. When I listened to FM radio, I couldn't hear it at the bottom of the hill. So which one's going to diffract more? AM radio. AM radio, if you look at the radio dial, is in kilohertz, thousands of hertz. FM radio is in megahertz. So smaller frequency leads to more diffraction. And finally, since wavelength is inversely proportional to frequency, as one goes up, the other one goes down, if we have a large wavelength, a big wavelength, then we're going to get more diffraction. So how are we going to get diffraction? Decrease the size of the opening, increase the wavelength, decrease the frequency of the wave. All right? The handout that I just gave you a couple minutes ago looks something like this. This is pretty complicated looking right now, although we're going to simplify it with some patterns. Again, today we're going to start joining some dots together and forming patterns like you did back in kindergarten in grade 1. What we have here is two openings. We got a wave approaching those two openings like this, and then that wave, as it goes through both of those openings, spreads out. Okay, in both cases, it forms these circular waves that go out away from these openings. So the pattern that you see up on the board right now is actually two diffracted waves. Every second line is a crest. Every second line is a trough. Let's label right now our crests and our troughs. The heavy lines on this diagram, we're going to say represent crests. The narrower lines are going to represent troughs. Can you see the difference there on the board between the heavy lines and the narrow lines? Okay, I think you can definitely see it on your paper, right? The heavy lines are going to be crests. The narrow lines are going to be troughs. When one crest encounters another crest, and that happens in the middle over here, right? Okay, we get crests from one wave encountering crests from the other, and troughs encountering troughs, and crests encountering troughs. When one crest encounters another crest, then what kind of interference are we going to get? What do you get? When a crest hits a crest, it forms a constructive interference. It forms a bigger crest, right? When a trough hits a trough, it forms a bigger trough, constructive interference. So what I want to do right now is go through this, and with red dots, or whatever color or symbol you're going to use here. Okay, you need two different colors or two different symbols. X's and dots work fine. Blue and red work fine. Okay, as long as you can distinguish between two different things. For me, with red dots, we're going to identify constructive interference, where crest meets crest or trough meets trough. Everywhere where solid line crosses solid line, or wide line crosses wide line, or narrow line crosses narrow line, we get constructive interference. That's when a crest hits a crest or a trough hits a trough. Let's go through this entire diagram and try to label all of those spots where we have constructive interference. Narrow line, heavy line, heavy line. There are way more intersection points than we're going to label here right now, because there are lots of intersection points that aren't constructive interference. So be careful. We're just labeling the ones where heavy meet heavy and light lines meet light lines. Now I'm going to draw a green circle. This green circle is going to represent destructive interference. Destructive interference occurs when a crest meets a trough. So in other words, on this diagram, when heavy line meets narrow line. So let's draw little green dots, or whatever symbol you're using, to represent where crest meets trough. Right here, here. Okay? Solid line or heavy line meets narrow line. We want to fill them all in. Don't just fill in what's left, because you might have missed one the first time. I want you to look at every point still and identify whether it's heavy and light line or heavy and heavy line. Now, besides our beautiful looking Christmas tree lights that we have set up here with red lights and green lights, we should start seeing some kind of pattern here. If we start connecting some lines together or some dots together, we should start seeing something like this. So what does that represent? Well, a red line is a line of constructive interference, as we've already said. That means that along that red line, we also call it an antinodal line, by the way. Along that red line, you will see big waves, big crests, and big troughs. You'll see crests that are twice as big as the crest you started with, and troughs that are twice as big as the troughs you started with. Really high amplitude waves as a result of this constructive interference. What are we going to see where we have the green lines? Well, that's destructive interference. We call those nodal lines. Where we have destructive interference, we see no waves. The crest met a trough and canceled it out. So now we just see calm water, if these happen to be water waves. If you happen to be lying on an air mattress enjoying the sun, trying to read a book, and you happen to be on one of these red lines, then you better hold on, because you're going to be bobbing up and down pretty big. That's constructive interference. You're going to have really big crests and really big troughs. Okay, it might be a fun ride. I don't know if it's so fun when you're trying to read a book, but really big crests, really big troughs. Constructive interference. If you happen to be sitting on, thank you. If you happen to be sitting on one of those green lines where we have destructive interference, you're going to be lying back, enjoying your book, enjoying the sun, not bobbing up and down at all, because the waves have completely canceled out. Now that's kind of hard to imagine, right? In one area where we see a red line, you're bobbing up and down like crazy. The guy next to you on this green line is just lying there enjoying the sun, not bobbing up and down at all. But then on the other side of him is another red line where the waves are going crazy again. Big constructive interference waves. That make sense? Next year in Physics 30, I want you to remember this, but you don't have to actually be able to remember it in detail for a test this year. Okay, this is just a little thing that we do in Physics 30. Okay, in Physics 30, we do this in the context of light. When light goes through two openings, we get the same pattern formed, except that we can't see the big waves and the small waves right here like we do with water waves. You can't lie on the crest and a trough of a light wave like you can the crest and a trough of a water wave. In order to see this in the context of light, we introduce a screen. We put a screen over here. And on that screen, areas of constructive and destructive interference get detected. We would see a bright spot right there. You would see a little flash of light right there in the middle, corresponding to the area of constructive interference. It would be a bright spot that would be twice as bright as the light would normally be, because it's constructive interference. Okay, right next to that, what would we see? Nothing, because these green lines are destructive interference. That's where we have the waves canceling each other out. If it's light waves, the light has disappeared because it's completely canceled out. Next to that, we have a bright spot again, dark spot, bright spot, dark spot, and so on. So if you held a piece of paper up here, right up here, you could see a bright spot, a dark spot, a bright spot, a dark spot, a bright spot, a dark spot, and so on, corresponding to the antinodal lines or constructive interference lines, and the nodal lines corresponding to the destructive interference. All right? Now next year we'll look at some equations that describe this as well, okay, how we can analyze this mathematically. This year we don't have to do that. Okay, this year we have to know what diffraction is. Okay, diffraction we looked at yesterday, we reviewed today the whole idea of the spreading out of a wave. Okay, we also have to know what interference is. We did look at that yesterday as well, right? Okay, crest and crest meet each other, form a really big crest. Trough and trough form a really big trough. Crest and trough, they cancel each other out. And we have to know how to put diffraction and interference together, like we have right here. Okay, next year again, we'll look at it mathematically, and we'll look at it in a little bit more detail in the context of light.